Hello and welcome. In this video, we're going to be discussing how to solve a word problem involving a quadratic equation. So let's read through this word problem. Suppose a ball's height h after t seconds is given by the formula h equals 2 plus 20t minus 5t squared. Find all values of t for which the ball's height is 7. Round answers to the nearest hundredth. So a couple things. I always like to start with the question part of the word problem, or what we're supposed to do. So let's just take a look at this sentence one more time. It says find all values of t, so that means we're not going to know what t is, we're trying to figure it out, for which the ball's height is 7. Well, if I look back at my formula, notice I've got two variables. I've got t, which is what we're trying to solve for, and I've got h, which was the ball's height. So what they're telling me is that the ball's height is 7 at the time for which I'm interested in figuring out t. So the first thing that I'm going to do is I'm going to take my 7 and plug it in for h. Okay, one thing you'll notice is that the equation that I just wrote is quadratic in nature. So if you didn't watch the video about solving quadratic equations using the quadratic formula, you'll want to do that before viewing this one. So if I'm going to solve this quadratic equation, I really have three methods. I can either try factoring it, I could use the quadratic formula, which would always work, or I can use the completing the square technique, which would also always work as well. Well, looking at this guy, first thing I want to do is let's get these terms all to one side of the equation. So you'll notice that my t squared term is negative. So instead of moving the 7 over, which kind of seems easier, I'm going to move all three of these terms over to the left-hand side because I want my t squared term to be positive. Okay, so if we do that, I'm going to add 5t squared to both sides. I'm going to subtract 20t from both sides. And I'm going to subtract 2 from both sides. So if we look at what's going to be left on the right-hand side, there's just going to be a 0 there. On the left-hand side, if we write our terms in order, I'll have 5t squared minus 20t, and then 7 and negative 2 is positive 5. So looking at that expression, to me, the numbers are, well, they're bigger. We certainly could try factoring it. One of the things that tips me off that it probably won't work to factor all that well is that you'll notice that they're asking us to round our answers to the nearest hundredth. And a lot of times when that's the case, it means that we're probably going to end up with an irrational solution. So I'm going to go ahead right away and use the quadratic formula just on a hunch. Okay, there's definitely no reason that I shouldn't try factoring first, but just on a hunch I'm going to try the quadratic formula. And again, the advantage there is the quadratic formula always works, whereas factoring, I could try it, and then if it doesn't work, I have to go back and use the quadratic formula anyways. So if we're going to use the quadratic formula, our first step is to identify what a, b, and c are. Remember that a is the guy in front of our squared term, so in this case a would be 5, the guy in front of our t squared term. B is the guy in front of our t term, so that's going to be negative 20. Remember, we keep the sign. And then our c value is the guy that's sitting all by itself, so that 5. And the quadratic formula, again, is a way for us to solve for, in this case, t, and it looks like this. It's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug in our values, we'll have t equals opposite of negative 20 plus or minus the square root of negative 20 squared minus 4 times a times c all over 2 times a. Okay, so if we just start simplifying, opposite of negative 20 is positive 20, plus or minus, if we simplify what's under the square root, negative 20 squared is 400. Negative 4 times 5 is negative 20, times 5 is negative 100. So underneath the square root, we're left with 400 minus 100 is 300. On the bottom, I have 10. Okay, now if you watch the other video about solving quadratic equations using the quadratic formula, at this point, I would have tried to simplify what's underneath the square root. But notice in this case, again, I'm not really interested in what we call exact answers. I'm going to end up rounding my answer to the nearest hundredth anyway. So at this point, what I'm going to end up doing is just running what I have through a calculator. So when I do that, the only thing I'd caution you about is that when you run it through a calculator, you want to make sure that you put your entire numerator in parentheses. And so I'm just writing out each solution separately, and I'm writing it the way that I would punch it into the calculator. So I'd have parentheses around my whole numerator and then divided by 10, and then the same thing for the second solution, parentheses around the whole numerator divided by 10. So if we do that with the calculator, we end up with two answers. The first one is 3.73 if we round to the nearest hundredth. The second one is 0.27. And those are both valid solutions. Okay, so here's a second example for you to try. So pause the video and then restart after you've given it a shot. Okay, so if we check this one out, notice there is a restriction here that t must be greater than or equal to 0. That means if we find solutions that are negative, we're going to have to throw those solutions out. Okay, so if we go through, let's start with what we're trying to do. Find all values of t for which the ball's height is 2. So they're telling me the ball's height is 2 at the time I'm interested in solving for t. So that means I can plug 2 in for h. So if we do that, we get 2 equals 3 plus 34t minus 16t squared. And then again, this is a quadratic equation, so I'm going to set it up for using the quadratic formula. So in order to prepare it, I need to move all my terms over to one side. And you'll notice that my squared term is negative, so I'm going to basically move all the terms from the right over to the left again. So I'm going to add 16t squared to both sides. I'm going to subtract 34t from both sides. And I'm going to subtract 3 from both sides. So if I do all that, I'm left with 16t squared minus 34t. And then 2 minus 3, those are like terms, that's just negative 1, equals, on the right side I have 0. And now this is all set up for me to use the quadratic formula. So my a would be 16, my b would be negative 34, and my c would be negative 1. So the quadratic formula is allowing us to solve for t. And the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug in our values, we get negative b, so I have the opposite of negative 34, plus or minus the square root of negative 34 squared minus 4 times a times c all over 2a. So if we just clean this up, opposite of negative 34 is positive 34, plus or minus, under the square root, we have 1156 is negative 34 squared, and then minus 4 times 16 times negative 1 is positive 64. So 1156 plus 64 gives us 1220 underneath the square root. And then in the bottom we have 2 times 16, which is 32. Okay, and again, notice that in our answer, we're supposed to round our answers to the nearest hundredth. So if I wanted exact answers, I would certainly try to simplify what's under the radical at this point, but because they're asking us to round our answers anyway, I'm just going to run our two solutions, or two potential solutions, through the calculator. So the first potential solution is 34 plus square root of 1220 over 32. The second potential solution is t equals 34 minus the square root of 1220 over 32. So if we run our first solution through, we get t equals 2.15. If we round to the nearest hundredth, that solution looks good because the only restriction was that t had to be positive. The second solution, when we run it through, we get t equals negative 0.03. Well, since it's a negative number, I have to throw it out because our restriction, if we go back to the beginning of the problem, was that t had to be greater than or equal to 0. So you can see that right here. So because I got that negative solution, I throw it out. That means my only solution is the 2.15.